in the previous lecture, we have started talking about the traits. In this lecture, we'll continue and I will show you some more examples. All right, so down here in our main function, I'll create a new function, just under, and I will call it, let's say, function logger or log info. Okay, log info function. And what this will expect as a parameter will be trait log type. Okay, let's say this will be value. It doesn't really matter how you call this parameter. And this will be something that implements log. IMPL like this, and this will implement log. So down here in the log info function, we are expecting the parameter that implements the log. So when I will access here value, I have only access to display info or alert something. You can see because that's what the log implementing. Log is implementing log is declaring here that we have a display info and alert something. So whatever type is implementing then the log, it has to also have these functions. Okay, so that's why we know that we can call here only these two functions. So value, and let's say alert something. And you can see it's working without any problems. Okay, so I'll remove this now, and I will write here log info. And now we can provide here either a person or animal. Okay, you can see I can provide here animal, or I can define here person, and that's it. Okay, if I would have here under struct, let's say struct city. All right, you can provide also string. All right, and let's create a city. So let city, and let's say name for a city, New York, string from New York, string from New York. Okay, if I will provide a city to log info, so we'll log here info for a city, you can see I cannot do it. I can provide here animal, no problem, but city doesn't implement the log trait, so I am not able to display here a city. Okay, so I can remove it. Okay, I'll also remove the city and also the struct of the city because I think now it's understood. Okay, what else we can do here? I will define here function, the same function. I will call it log info2, and I will show you how you can write differently. Okay, and I will tell you what's the difference. Okay, so log info2 will also take the value that implements the log, but I will write here value of the type a reference to the log. You can see I'm not allowed to do it. I will hover over. The trait object must include the dynamic keyword. So now I have to provide here dynamic keyword log, and I can do the same thing. And it behaves exactly the same. So I will write here, for example, log info2. I'll provide here animal. It will work without any problems. Of course, I need to provide here reference to the animal now. A reference to the animal. That's what I'm specifying here. Okay, so now I will write here cargo run. You will see the same thing. Animal implementation, default implementation. So it's working. Okay, so what is the difference between the implementation here? That's something that implements the log, and that's something called dynamic here. Okay, so I will add a couple of comments. Dynamic is short for dynamic. Okay, so there is something called dynamic dispatch that is that's happening in the background at the runtime when the function is executed, because the function in advance doesn't know if you will be passing here that object of the animal or you will be passing here a person. It has to resolve at the runtime. So that's why we need to provide this dynamic to inform the function about the fact that you can receive here either animal in this case or the person, and the function should perform something called dynamic dispatch. Okay, I can write here. Okay, so a dynamic is short for dynamic and refers and says that function should perform dynamic dispatch. Okay. Okay, so basically decision of exactly which function to call at the runtime. Okay, so that's the case. That's the case when you're using dynamic. what's the then now implementation syntax? What is this? Actually, IMPL makes the compiler determine type at the compile time. So what will basically happen when the compiler sees that you have a log info with the log here, it will create in this case, because we have two structs that implements the log, it will create two different versions for a log info. Okay, it will create, in the background, it will create a log info for the person, and it will create a log info for the animal. Okay, this will happen at the runtime. Of course, these functions are called differently at the runtime. Some change names and so on, and that will happen at the compile time. My mistake. This will happen on compile time, and you have two different versions for this function. Okay, so there are benefits, so there are cons. As you can see here, the benefits of this here of the dynamic is that the compilation file will be smaller, so the final file will be smaller, so smaller size of the final file, because in this case you will have only one version of the function, but when you want to call the function, it will be a little bit slower than this version here. But this version here will create as many functions as many traits you are implementing here. The log is implementing on. Okay, so in this case it's just a 2, but if you have a multiple other types on which you're implementing log, the different versions of the functions will be created, and it will create a bigger build time and the bigger the final size of your compiled source code. Okay, so IMPL makes the compiler determine the type at the compile time. It will create multiple versions of the function depending on how many types implement log. Okay, so it will create multiple versions of the function depending on how many types log trait implements. In our case, it will be just for a person and for animal. Okay, so that's the main difference. I will not get into much details here. We'll be not, I guess we'll be not using any traits in our practical application. Just for you to know, if you want to take a look at the documentation, it's a very heavily used topic. So I suggest you to maybe also to read something in your free time about this. Okay, guys, so that's gonna be it, and I hope to see you next lecture. Cheers.